and welcome to class. I shall discuss the concept of linear combination. To get hold of the concept of linear combination, I will begin by letting A be a set that is filled with finite points. Let A be a set that is filled with finite points. Let's say x1, x2, x3, and if I should make an omission to xn. Okay. Now this three dots is called, we call it ellipses. This indicates that there is an omission in the listing of the elements of A, and so long as it terminates in xn. Okay. Now if I multiply each element of A by scalar value, which is by numbers, let's assume the scalar value that will multiply x1 to be alpha 1. Let the scalar value that will multiply x1 be alpha 1, and the same thing, let the scalar value that will multiply x2 be alpha 2, and also for x3 let the scalar value be alpha 3, and also if it continues, let the xn be multiplied by scalar alpha n. Now taking the product, you see that the product between x1 and x and alpha 1 will give us x1 alpha 1. Or let's alpha come first. Let the scalar come first. We have alpha 1 and x1. The product between x2 and alpha 2 becomes alpha 2 and x2. The product between x3 and alpha 3 becomes alpha 3 x3. In the same way, the product between xn and alpha n becomes alpha n xn. Now if I sum the outcome of the product, if the outcome of the product is taken, the sum is taken, we obtain, which is when you take the sum of the result of each product. We have alpha 1 x1, alpha 2 x2, alpha 3 x3. There's an omission of the sum. Then we have alpha n x n. See, we obtain a mathematical expression. So we call this sum mathematical. It becomes a mathematical expression. Now, if this particular sum amounts to y, maybe if the sum, this particular sum, if it's equal to y, hence we obtain the mathematical equation y to be this particular sum. Call this equation 1. Then hence we say that y is the linear combination of x1, x2, x3 to xn, because there is this scalar alpha 1, alpha 2, alpha 3 to alpha n, such that y is equal to this particular expression. Now, for the sake of simplicity, I can introduce the Greek capital letter called sigma so as to make this equation 1 computable. Y now becomes the summation sign sigma is given, and we have 1, we have 2, we have 3 to n. So our index I will begin with 1 and our index I will end in n. So long as n is here, it ends in n. Then we have alpha I, xi. So this formal sum, this is a formal sum, this is a formal sum, this formal sum implies that y is a linear combination of x1, x2, x3, and xn. Don't forget this is called ellipsis because there is an omission in the listing of the elements of A. At the same time, try to understand that this I here is called what? The index. Y1 is called the lower limit because it's where I starts from. Yn is called the upper limit. Xi for each I, you see that xi belongs to A, while alpha I is what? Is a scalar. The scalar value for each I. At the same time, we would note that the cardinality of this alpha is the same as the cardinality of the element of A. That is, the cardinality of this particular scalar is equal to the cardinality of the element of A. Hence, Y is a linear combination of x1, x2, x3 if there exists a scalar value such that Y is equal to this particular sum. Thanks for watching.